Hello everybody to Everyday Lead Code, and this is Teet Doshi. This is my ninth video, I guess, and I know I've not been uploaded two videos in the last 2 days because ninth and 10th, I think I didn't upload. The last video upload was 8th, and I missed it out. I was doing some uh, random things in the last 2 days, adding, dropping classes, and all these things. Anyways, not really relevant for you. Um, So what problem we are going to solve is the rotate image problem. Honestly, this is not a very difficult problem. I got it in the first go itself, uh, passing all the test cases, but it's a very famous interview question. So I would like to, post this one. Uh, so it clears transpose of a matrix a little bit. So anyway, so like every time we just understand the problem and we observe things. And this problem is rotating an image. So you are given an image in a matrix form. Now, when you are given an image in a matrix form and you are asked to rotate it by 90 degrees, and you're told that you need to rotate this in place. So how would you do that? That's the question. So for an example, if you had a 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, or this is my rough work here. If you had a 1, 2, 3, a 4, 5, 6 here, 7, 8, 9, you can just imagine the uh, image is getting rotated 90 degrees this way. So if you see the first row, it will come this way. So the first row comes here in the last column. The second row will come in the second column. So second row comes in the second column, and the third row after doing this comes here. So in the first column. So my answer would be because I rotated this way, 1, 2, 3 will come here, 2, 3 will come here. Then I see this 4, 5, 6 will come here. 4 is here, 5 is here, 6 is here, and 7, 8, 9 naturally comes here. 7, 8, 9 naturally comes here. So obviously I tried some solutions for 10 minutes. I couldn't really come up with, but I got it eventually in the I think the 11th 12th minute or something. I got it. So what I observed is the key observation here is when I transpose this matrix, what happens? The row becomes column, the column becomes rows. So 1, 1, 2. Actually, I'll put it here. 1, 2, 3 comes here. 1, 2, 3. Then you have a 4, 5, 6. Then you have a 4. You have a 5. You have a 6 here. You have 7, 8, 9 here. 7, 8, and a 9 here. So I saw that this is the transpose of the matrix. I saw my answer. When I compared with my answer, what we can observe is 7, 4, 1 is exact. So I'm getting the transpose here. But if I reverse it, I just get 7, 4, 1. If I reverse 8, 5, 2, I will get 2, 5, 8. And if I reverse 2, 5, 8, I get 8, 5, 2. If I reverse 3, 6, 9, I get 9, 6, 3, and that's how I get the answer. So the solution was very simple, getting the transpose, and after getting the transpose in place, I can just reverse the first row, the second row, the third row. And how do you reverse the rows? And if you are following my videos, in the next permutation problem I solved it. We keep 2 pointers here, we keep swapping, we decrement, we keep swapping, decrement, increment this guy, increment this guy, decrement this guy, swap, and keep on doing this until they cross each other. So that's what we actually did, and we got this answer. So I'll just walk through the code once, since it's not very difficult. I'll not really take more time, and I've been taking a lot of time. Yeah. So 1 4 1 2 3 is here. So when I want to convert it into a transpose matrix, um, what you need is something like this. uh, this 0 0 gets converted to a 0 0, so don't really matter, doesn't really matter. What I'm trying to do is 0 0, then 0 1 comes here, this guy comes here, this guy comes here, this is swapped like this, and 7. Now I start my column from so when I go walk here, I check the column from this guy. So okay, so what I do is, since I've completed this row, I do not really want to touch this row. So, and I've completed this column, so I don't really want to touch this column now. Now when I'm in the second row, I just start with a 5. 5 is swapped with a 5, so no problem. 6 will be swapped with an 8. So 6 comes here, the 8 comes here. Now when I come in the third column, I just look at the 9 and I just swap 9 and 9. It's the same thing. So because this is a of 2 2, I just swap a of 2 2 with a of 2 2, and it's the same thing. uh, Nothing happens after a swap of the same element. Okay. 1 4 7, so I get the transpose of the matrix, and then I keep one pointer here, I keep one pointer here, I keep swapping them until they cross each other. So 7 comes here, 1 comes here. If you want to walk through it, we can really walk through it. Yes, 7 comes here, 4 comes here, 1 comes here. Then the pointer is at 2, one pointer is at 8. You swap, 8 comes here, 5 comes here, 2 comes here. This is decremented, this is decremented. Because they become equal, we come out of that loop. Then you have 3 6 9 to be reversed. That would be one pointer at 9, one pointer at 3. 9 comes here, they swap, 3 comes here, 6 remains as it is, because at that particular point the start and the end pointer will become equal. So we'll walk through the code once. So definitely I start from I is equal to 0, I is less than the matrix size. So I'm just walking through the row. I'm walking through the column from I. That's all that is needed here. Otherwise, everything is very common. Swap matrix of ij with your matrix of ji. You swap, you get the transpose, and here I have just reversed the string. Sorry, not the string. I have just reversed that particular row, this row, next row, next row. I keep walking through the rows. This is the walkthrough from the rows, and within that, it's just swapping. That reverses the array. So that's it for today. I know it's a small video, but yeah, that's it for today. Thank you.